All right, welcome back. Here we are. A lot you didn't see me do. I took the long ones, I cleaned them up, I deburred everything just in case. The machinist and me made sure that every surface that was touching was deburred and sanded flush. Did all that, cleaned it with acetone, put on a bunch of clamps, and then I measured it. And it wasn't perfectly flat, and went about cajoling it a little bit into shape. So this is how far I've gotten. I can't get any closer. I've got clearly right here, there's kind of a crown right in this area, but it's mostly centered around here. And you can see I was going through with the feeler gauge just to figure out how much crown I had. And that's based on these. So really it's a secondary measurement. That wouldn't be my primary. That would be my first choice, but that's what I got. And this comes from a recommendation from weld tables from tab and slot. Now, let me back up for a second. If you look at all the online YouTube videos for making one of these, they're gonna have you clamp this all together, flip it over, check for flatness, adjust, which they don't say how, then flip it back over. Then they're gonna have you put welds in, spot welds between the table and the ribs, right? Like just a few. And the idea is to do short spot welds to minimize the heat. That seems to make sense in the surface, but I don't really like it because I don't want to pull the ribs into the table in specific stress concentrators. So I was looking at alternative ways, and I was thinking if nothing else, I'll do it at the tab. So it'll pull in on the tab a little bit, it won't pull on the table. They were doing it like here and corners and stuff, I don't like it. So that was my plan, was to do it at the tabs. But then I did a little bit more research, and in old videos from tab and slot or weld tables, whatever you want, are very clear on this point. The engineer that designed these dog bones for this tab and slot had a very specific design intent. And I really wish they had written this down or sent it with the instructions. The intention was to build it all upside down like this, check for flatness against the ribs, because the ribs should be within 0.03 of an inch of each other, which, based on my measurements, pretty close. I really haven't found any reason to doubt that. And then do kind of what I've done here, bang it around, and what they don't really explain, but it's kind of obvious if you've done this before, if you've like had to tram a mill or something. Like the friction between these two surfaces right here is what's holding it together right now. So if there's a little bit of a bend, if by banging it, you actually break that friction and you get a new friction spot, right? So you can actually get this bow out of here. I did a little bit of that, but I can only get so far with this. I don't think there are enough supports, enough ribs, and enough friction to hold this bow from going back. I really cranked down on these, and I'm pretty much at the end of those. So I've got as much going for me as I can. Really, my goal was to get under 10 thousandths. I don't know when I flip it over what it's going to be, but we'll find out. But the next step on this, and this is critical, is to weld right where the two connect between in the ribs. No welding to the table. Do one side and then do the exact opposite side right here in close succession, so it's still hot, right? So when they shrink this way. They shrink in towards each other. And really, that's not going to have anything to do with the flatness of the table, and it's really going to stiffen the structure a little bit. So that's actually pretty good. So you do these, skip around, kind of good, practice there. Once you do that, you flip the table over clamped, and at this point, the top's still not connected, and then you weld only inside of the slots. And it's kind of ingenious, probably pretty standard, but I don't have a lot of experience with tab and slot. If you look, I'm gonna look underneath here for a second with you. If you look at one of these tabs, like this one right here, you've got the risers of the tab here, and then it's got a dip, which makes it almost flush with the bottom of the table surface. The idea is to put the weld only in the middle here that grabs the three faces here, 1, 2, 3. And since that face is going to be heating this surface in the middle, it should be pulling, theoretically, and semi-probably truly, the top and bottom surfaces fairly evenly. So it's not inducing a warp. It might induce a pucker locally here. but it shouldn't induce a warp. So I suspect there might end up being like a little low spot right around this. But again, you limit your heat input somewhat. And since by doing it deep and doing these 3 in a plug weld, it'd be really strong. But you know, before you do that, they have you tack it on one side, check for flatness again. You might have to bang it around a little bit. You might get somewhere with that. I'm not sure. That might be true, but if nothing else, the structure underneath is pretty flat. So that's the method I'm going to take because it makes a lot more sense to me. And the engineer said that's the way it was designed, and it makes, and you know, they did it with a SolidWorks presentation, which always endears me to somebody. So anyway, now that I've got this, it's time to break out the welder. And I'm gonna start welding this up. Start from the inside, 1, 2, 3, 4. Then I gotta figure out where I'm going from there. Probably go here, then here, and then corners. Probably do the corners last. So first real test of welding, since you know I'm not really good at it, but probably good enough to do this, one would hope. So here goes. Alright, so how did that go? Well, 60%? Kind of. Good enough to hold it together, that's for sure. Now this is going to be hot, so I gotta be careful of that. It's not obviously hot, but let's see if anything really changed here. It pulled on the outsides a little bit, ironically. This side pulled down, which was the highest side, so that's kind of interesting. Yeah, this side pulled down. Interesting. And then it bowed up again. Oh, that's pretty significant right there. What happened there? Well, we'll check it when we flip it. As I'll take the clamps off. That might be it for tonight. I think I'm gonna let it cool off overnight. Check it tomorrow. All right, talk to you later. Bye. Okay, we're back. So, I spent some time shimming this, and it feels a lot like sweeping a really poorly maintained mill. The gist is that I found overall there was up to 30 thousandths of differential on this thing. So what I ended up doing is I tried all sorts of clamping, and initially the frame underneath had biased this into an opposite bow, but then as the metal relaxed and it cooled down, the bow came back, which is fine. And it's really bowed this way. So that's the way the sheet bowed. There's really very little bow this way, but especially on the edges, there's kind of a fall off a little bit. So kind of like, and it tends towards more this side to be bowed more on this side. So what I ended up doing, effectively what we have is two assemblies here. We have the top and we have the frame. The frame's all welded up, and it's more rigid than the top, but it still can give some. So what we're finding is when we bolted the top down flush and we made sure everything was close within a few thousandths, we made it flat, but it still flexes. So when I unscrewed everything, it kind of flexed back. So now what I'm doing is I'm having to put the top on it, pull this down, but when I'm pulling it down, it can only pull it but so far, so I have to almost force the edges up, which I've done with shimming. So I've taken some random scrap sheet metal I had, and in one extreme case, a penny, and shimmed these edges up to force the reverse bow, and I held down the center with the U-bolts. So it took a lot of cajoling, a lot of fine tuning with a very heavy hammer, and a lot of cranking on moving these clamps around and these U-bolts. I found this to be kind of the optimum configuration. It's not many because I'm holding down the middle and I'm shimming out on the outside, and just like 4 locations, kind of, it's like one here, one here, one here, and one here, or something like that. Like there's like 4 locations where there's shims. Finding the absolute most effective spot, because I can only do where the ribs are, and they're about roughly a foot on center. So I don't have a lot of space in between these. I don't have a lot of control. But I think I got it now to within, under 10 thousandths flatness. Obviously that's going to change a little bit when I weld, so now I've got to figure out what my order of operation is for welding. My thoughts right now are to tack weld this center rib. So tack weld the center rib down, check everything, readjust, shim, whatever I need to do, and then start skipping around, tack weld the rest. Might do one side then the other. I haven't decided yet. Anyway, that's what we're going to do now, and if that all works out, I will let you know. All right. Okay, so it's all tacked up. There's definitely some sounds of movement while that was happening, but I checked it every so often. It didn't seem like it was moving any more so than I had seen in the past. So really the only low spot is right here. There's like a really limited low spot right there. I do have shims in strategic places, but it's so low. It's like 15 thousandths. I don't have 15 thousandths worth of shim. I only had 30 thousandths as my smallest shim, so when I forced it in there, it really made it worse. So I'm gonna have to live with that. But you know, I've been using a 5 thousandths feeler gauge for everything. It's right at 5 right there. This is the bad spot right here. Like right here it's good, but right here it's not. It starts right there. It's right there. It's a low spot, but it's limited because it's not on this side. On this side it's not low. On this side we're good. Right. So it's really just this pocket, which is a little annoying, but just the way it works. But it seemed like everything held. These tacks are pretty wimpy, I'll be the first to admit. Semi-intentionally, semi because I'm not good. But you know thyself. So I'll go this direction. A little higher there, maybe 7 thousandths or so. Have to take a weld stab on this one. It seems to be okay. So it's just that corner, which, all right, I'm not gonna lay stuff out on corners. So if I do, I'll probably get a vise or something. Yeah, so nothing seems to be. There's like 7 in that corner, maybe 10 right here. Otherwise, all under 5. So that seems pretty good. Probably going to go ahead and plug weld these. Learned a lot about plug welding and just these tacks. Firstly, I stink at it. And secondly, it really doesn't take as much heat as I thought. I was putting too much heat into it. And also because these are deep plug welds, I was dipping the tungsten a lot, which you probably saw me, embarrassing. I have to swap it out a couple times. But I don't know how embarrassed I really am. I'm definitely a novice. This is probably, probably got like 40, 50 hours of welding in, so nowhere close to what I would consider like the amount to be decent, which is around 1,000. So we'll call that good. I'm going to go ahead and plug weld all this, and I don't know if I'll finish it tonight, but that's the last thing I'll do, and then because it's going to be hot when I finish it, but I'll definitely have to skip around because I'm going to be putting a lot of heat into this. So I got to think about my sequencing a little bit. These crosses are a lot of metal. I might wait for last on those so everything else is solid, just because there's so much heat going in with one of those crosses, and probably the ends too because they can move the most. So probably start with these middle ones, move to the edges, and then do the crosses. So yeah, a lot of welding. Let's get to it. Well, not all entirely done, but pretty close, just a few crosses left. I'll let it cool down a little bit. There's a lot of movement, so I'm going to check it. Not that there's much I can do at this point, but, you know, I'm a sadist and I want to see where everything went wrong. And I have to say, I need to practice more plug welds, because about half of them are okay looking, and the other half look like complete trash. Like one of them looks like I know what I'm doing, so. But all a whole, I'm pretty sure of that. There's plenty of heat. Lots of stuff got melted. The question is, did I work it all to hell? And I did it. It's alright. I mean, that's the top spot right there. Just got one load star right, one star right there. Double back. Probably on this corner, on this edge, but to be expected, this is the problem one right here. Yeah, it's the same. And this one's still good. Yeah, I mean, it's probably within 10 thousandths. Frankly, I'm going to go back over these plug welds and make them look prettier one of these times. I'm going to finish up a couple crosses left. I'll let this cool off a little bit. And I think I'm effectively done with this. Tomorrow I'm going to probably re-weld a lot of these bad ones. Just smooth them out because they just look nasty. And then I'll probably sand the whole top. And next vlog I'll probably talk about it and show you the pictures of the final product, because I'm going to sand the top and make it nice and pretty, polish it up. Probably still stay just like this though. I mean, I got nowhere else to put it right now. The next thing to do is make some clamps for it. I've got some donor clamps in mind because they're not very good clamps to start with, but they'll be great for this. Alright, that's all I got.